name is Tommy, and today we're talking about net ionic equations. So write the balanced equation representing the chemical reaction of sodium reacting with water. And the hint is that it forms NaOH and H2. So first of all, we have our sodium, so Na, which is a solid, plus H2O, which is a liquid. Normally it's like in a line, but for right now, dealing with space, we're just going to have it like this, stacked on top of each other. NaOH, which is a gas, plus H2, which is also a gas. Okay, so first we want to recognize that we want the same number of atoms for each element on the same, or to be equal on both sides. So we have one sodium, great. We have 3 hydrogens and 2 hydrogens, which is not so great. 1 oxygen and 1 oxygen. So because of that mismatch with hydrogens, we have to balance this. So if a common way I like to do it is think about this in terms of ratios. So we have a 2 to 1 hydrogen oxygen ratio no matter how we split it for the reactants. So we want that same thing to happen here. And the way we can do that is by putting a 2 in front of sodium hydroxide, because we'll get 2 hydrogens and 2 oxygens. So 2 plus 2, 4 hydrogens to 2 oxygens, that's 2 to 1, like we have with reactants. So now all we have to do is balance it. So if we have 4 hydrogens and 2 oxygens, we can get that by doubling our water. And that'll give us 4 hydrogens, 2 oxygens. And the only thing left is that we need our sodium to be the same. So we have 2 sodiums down here now. So 2. And we have our balanced reaction of 2 sodium, 2 waters, 2 sodium hydroxides, and 1 H2. For this problem, we have to write the net ionic equation for the reaction between NaCl and AgNO3. So they're both aqueous, so they're both going to be dissolved in water. So NaCl, aqueous, plus AgNO3, aqueous, produces or yields sodium nitrate, aqueous, and AgCl, which is actually going to be a solid because it's insoluble. So it will form a precipitate at the bottom, which is something I'll cover later. Okay, so when something's aqueous, what we can do is that we can split it apart into its ions. So we have Na plus aqueous plus Cl minus aqueous plus Ag plus NO3 minus, both these are aqueous, yields, I'm going to have to stack this, Na plus aqueous plus NO3 minus aqueous plus, since AgCl is a solid and not aqueous, we cannot separate it. So we just keep it as AgCl, solid. So what ends up happening is that, as you can see, we have things that are on one side and are on the other side. So nothing happens with them. They're just kind of sitting there. And that's why we call them spectator ions. So if you see ions that are on both sides, you can cancel them out. So Na plus cancels Na. Sodium is a spectator ion, and nitrate cancels. So what we're left with is Ag plus Cl minus yields AgCl. So aqueous. And that would be your net ionic for the reaction between NaCl and a silver nitrate.